All right, we are now down to section 6. Section 6 says, in the first part of this lesson, we showed that for two independent events, the probability of A given B equals the probability of A. In a previous activity, we showed that for two events, A and B, the probability of A given B equals the probability of A intersect B over the probability of B. Substitute probability of A for probability of A given B and rewrite the equation. The probability of A intersect B over the probability of B should equal the probability of A. So what they did was they just replaced these. They put the probability of A here, substituted it in. Next, multiply both sides of the equation by probability of B. We see that it is equivalent to saying that the probability of A intersect B equals the probability of A times the probability of B. Now we know the following. The events A and B are independent if and only if the probability of A intersect B equals the probability of A times the probability of B. So for independent events, in order to find the probability that both events will happen, you multiply the probabilities of the events. That is, if A and B are independent events, then the probability of A and B equals the probability of A times the probability of B. Note that this rule tells us two things. First, if A and B are independent events, then the probability of A intersect B equals the probability of A times the probability of B. Second, if probability of A and B equals the probability of A times the probability of B, then A and B are independent events. 8. Recall the information about the houses on Hector Street. Probability of G equals 0.25. Probability of F equals 0.76. And the probability of G and F is 0.19. And use the formula above to show that G and F are independent events. Okay. Clean this up. We know that the probability of G and F equals 0.19, right? We know that the probability of G times the probability of F equals 0.25 times 0.76. This equals 0.25 times 0.76. It equals 0.19. And since the probability of G and F equals the probability of G times the probability of F, G and F are independent events. Okay. Let's move on to question number 9. Question number 9 says, suppose that you flip a coin and you roll a cube with faces numbered 1 through 6. Make sense of problems. Explain briefly in words how you can know that the events of the coin lands heads up and the cube shows a 6 are independent. Well, knowing that a coin lands heads up or not, heads, it should have been heads up. does not change the probability that the cube shows a 6. So we're going to go back and put this as up. Okay. So knowing that a coin lands heads up does not change the probability that the cube is going to show a 6. So we would expect these two events to be independent because one does not affect the other. But let's see if the numbers show us the same. What is the probability that a coin will land hands up and the coin, should say the cube. Should say cube. And the cube will show a 6. Okay, well, the probability of heads and a 6 equals 1/2, because half the times you're going to land on heads. And this should be 1/6 because there's only 1 6 on the entire 6-sided die, which equals 1/12, because 1 times 1 is 1, 2 times 6 is 12. Let's take a look at number 10. When a student is selected at random from Annabelle High School, let G be the event that the student's average grade is over 90, and let S be the event that the student lives in the southern part of town. You are given the probability of G equals 0.29, and the probability of S is 0.42, and that G and S are independent events. When a student is selected from Annabelle High School, what is the probability that the student has an average grade over 90 and lives in the southern part of town? Well, we're told that these are independent events. So we could find this by saying the probability of, that should say G and S probability of G intersect S equals, remember that we can go back to this equation. The probability of G and S equals the probability of G times the probability of S because they are independent. So we can say 0.29 times 0.42. Okay, so we got 0.29 times 0.42, and I am getting 0.1218. When a student is selected at random from Annabelle High School, what is the probability that the student has an average grade over 90 or lives in the southern part of town? Note the addition rule can be used to answer this question. So this time we're finding the probability of G or S. So this is going to equal 0.29, which is the probability of G, plus 0.42, which is the probability of S, minus 0.1218, which is the probability of both. So I've got 0.29 plus 0.42 minus 0.1218, and I am getting 0.5882. And let me go back and fix this. This should be a G. On to your debriefing question for this section.